Assalamualaikum everyone, welcome to College Physics. Today we'll be discussing the scheme of work of Cambridge IGCSE 0625/0972. The main contents that we'll be introducing. Number 1, motion, forces and energy. Number 2, thermal physics. Number 3, waves. Number 4, electricity and magnetism. Number 5, nuclear physics. Number 6, space physics. Each page will contain the key concepts, which in this case is pressure, and the learning objectives, which basically explains the key concept further. We will be discussing each key concept and its learning objectives. Number 1, motion, forces, and energy. Key concept. 1.1.1, physical quantities and measurement techniques. Learning objectives. Describe the use of rulers and measuring cylinders to find a length or volume. Describe how to measure a variety of time intervals using clocks and digital timers. Determine an average value for a small distance and for a short interval of time by measuring multiples, including the period of oscillation of a pendulum. Key concept. 1.1.4, physical quantities and measurement techniques. Learning objectives. Understand that a scalar quantity has magnitude only and that a vector quantity has magnitude and direction. Know that the following quantities are scalar: distance, speed, time, mass, energy, and temperature. Note that the following quantities are vectors: force, weight, velocity, acceleration, momentum, electric field strength, and gravitational field strength. Determine by calculation or graphically the resultant of two vectors at right angles limited to forces or velocities only. Key concept. 1.2.1, motion. Learning objectives. Define speed as distance traveled per unit time. Recall and use the equation v is equals to s upon t. Define velocity as speed in a given direction. Recall and use the equation average speed is equals to total distance upon total time taken. Define acceleration as change in velocity per unit time. Recall and use the equation a is equals to delta v upon delta t. Note that a deceleration is a negative acceleration and use this in calculations. Key concept. 1.2.4, motion. Learning objectives. Sketch, plot, and interpret distance time and speed time graphs. Determine quantitatively from given data or shape of a distance time graph or a speed time graph when an object is A, at rest, B, moving with constant speed, C, accelerating, D, decelerating. Calculate speed from the gradient of a straight line section of a distance time graph. Calculate the area under a speed time graph to determine the distance traveled for motion with constant speed of constant acceleration. Key concept. 1.2.10, motion. Learning objectives. Determine from the data or from the shape of a speed time graph when an object is moving with A, constant acceleration, B, changing acceleration. Calculate acceleration from the gradient of a speed time graph. State that acceleration of free fall g for an object near to the surface of the earth is approximately constant and is approximately 9.8 meters per second squared. Key concept. 1.3.1, mass and weight. Learning objectives. State that mass is a measure of the quantity of matter in an object at relative rest to the observer. State that weight is a gravitational force on an object that has mass. Define gravitational field strength as force per unit mass. Recall and use the equation G is equals to W upon m, and note that this is equivalent to the acceleration of free fall. Note that weights and masses may be compared using a balance. Describe and use the concept of weight as the effect of gravitational fields on a mass. Key concept. 1.4.1, density. Learning objectives. Define density as mass per unit volume. Recall and use the equation P is equals to mv. Describe how to determine the density of a liquid, of a regularly shaped solid, and of an irregularly shaped solid, which sinks in liquid volume by displacement, including appropriate calculations. Determine whether an object floats based on density data. Determine whether one liquid will float on another liquid based on density data, given that the liquids do not mix. Key concept. 1.5.1.3, effects of forces. Learning objectives. Determine the resultant of two or more forces acting along the same straight line. Know that an object either remains at rest or continues in a straight line at constant speed unless acted on by a resultant force. State that a resultant force may change the velocity of an object by changing its direction or motion of its speed. Recall and use the equation F is equals to ma and know that force and the acceleration are in the same direction. Key concept 1.5.1.6 Effect of forces. Learning objectives. Describe solid friction as the force between two surfaces that may impede motion and produce heating. Know that friction or drag acts on an object moving through a liquid. Know that friction or drag acts on an object moving through a gas, e.g. air resistance. Key concept 1.2.13 Motion. Learning objectives. Describe the motion of objects falling in a uniform gravitational field with and without air-liquid resistance, including reference to terminal velocity. Key concept 1.5.1.1 Effects of forces. Learning objectives. Know that forces may produce changes in the size and the shape of an object. Sketch, plot, and interpret load extension graphs for an elastic solid and describe the associated experimental procedures. Define the spring constant as force per unit extension. Recall and use the equation K is equals to F upon X. Define and use the term limit of proportionality for a load extension graph and identify this point on the graph. An understanding of the elastic limit is not required. Key concept 1.5.3.1 Center of gravity. Learning objectives. State what is meant by center of gravity. Describe an experiment to determine the position of the center of gravity of an irregularly shaped plasma plane lamina. Describe quantitatively the effect of the position of the center of gravity on the stability of simple objects. Key concept 1.5.2.1 Turning effects of forces. Learning objectives. Describe the moment of a force as the measurement of its turning effect and give everyday examples. Define the moment of a force as moment is equals to force into perpendicular distance from the pivot. Recall and use this equation. Apply the principle of moments to situations where one force each side of the pivot, including balancing of a beam. State that when there is no resistance momentum, an object is in equilibrium. Apply the principles of moments to other situations, including those with more than one force on each side of the pivot. Describe an experiment to demonstrate that there is no resultant momentum in an object in equilibrium. Key concept 1.5.1.12 Circular motion. Learning objectives. Describe quantitatively motion in a circular path due to a force perpendicular to the motion as A. Speed increases if force increases with mass and radius constant. B. Radius decreases if force increases with mass and speed constant. C. An increased mass requires an increased force to keep speed and radius constant. F is equals to mv squared upon r is not required. Key concept 1.6.1 Momentum. Learning objectives. Define momentum as mass into velocity. Recall and use the equation P is equals to mv. Define impulses as force into time for which force acts. Recall and use the equation impulse is equals to F delta t is equals to delta m into v. Apply the principle of the conservation of momentum to solve simple problems in one dimension. Define resultant force as a change in momentum per unit time. Recall and use the equation F is equals to delta p upon delta t. Key concept 1.7.1.1 Energy, work, and power. Learning objectives. State that energy may be stored as kinetic, gravitational potential, chemical, elastic, nuclear, electrostatic, and internal. Describe how energy is transferred between stores during events and processes, including examples of transfers by forces, mechanical working, electrical currents, electrical work done, heating, and by electromagnetic sounds and other waves. Note that the principle of conservation of energy and apply this principle to simple examples, including the interpretation of simple flow diagrams. Key concept 1.7.2.1 Work. Understand that mechanical or electrical work done is equals to the energy transferred. Recall and use the equation for mechanical working. W is equals to Fd is equals to delta E. Key concept 1.7.1.4 Energy. Recall and use the equation for kinetic energy. E is equals to half mv squared. Recall and use the equation for the change in gravitational potential energy. Delta E is equals to mgh. Key concept 1.7.3.1 Energy resources. Describe how useful energy may be obtained or electrical power generated from A. Chemical energy stored in fossil fuels. B. Chemical energy stored in biofuels. C. Water, including the energy stored in waves, in tides, and in water behind hydroelectric dams. D. Geothermal resources. E. Nuclear fuel. F. Light from sun to generate electrical power. G. Infrared and other electromagnetic waves from the sun to heat water, solar panels, and to be the source of wind energy, including references to a boiler, turbine, and generator where they are used. Describe advantages and disadvantages of each method in terms of renewability, availability, reliability, scale, and environmental impact. Understand quantitatively the concept of efficiency of energy transfer. Know that radiation from the sun is the main source of energy to all our energy resources except geothermal, nuclear, and tidal. Know that the energy is released by nuclear fusion in the sun. Know that research is being carried out to investigate how energy released by nuclear fusion can be used to produce electrical energy on a large scale. Key concept 1.7.4.1 Power. Define power as work done per unit time and also as energy transferred per unit time. Recall and use equations. P is equals to W upon T. B. P is equals to delta E upon T. Key concept 1.7.3.1 Energy resources. Define efficiency as percentage efficiency is equals to useful energy output upon total energy input into 100. B. Percentage of efficiency is equals to useful power output upon total power input into 100%. Recall and use these equations. Key concept 1.8.1 Pressure. Learning objectives. Define pressure as force per unit area. Recall and use the equation P is equals to F upon A. Describe how pressure varies with force and area in context to everyday examples. Describe how pressure beneath the surface of a liquid changes when depth and density of the liquid changes. Recall and use the equation for the change in pressure beneath the surface of the liquid. Delta P is equals to PG delta H. Number 2. Thermophysics. Key concept 2.1.1.1 States of matter. Learning objectives. Note that the distinguishing properties of solids, liquids, and gases. Note the terms for the changes in state between solids, liquid, and gases. Gas to solid to gas, transfers are not required. Describe the particle structure of solids, liquids, and gases in terms of arrangement, separation, and motion of the particles, and represent these states using simple particle diagrams. Describe the relationship between the motion of particles and temperature, including the idea that there is the lowest possible temperature, negative 273 degrees Celsius, known as absolute zero, where the particles have least kinetic energy. Convert temperatures between Kelvin and degrees Celsius. Recall and use the equation. T, temperature in Kelvin, is equals to theta in centimeters plus 273. Key concept 2.1.2.3 Particle model. Describe the pressure and the changes in pressures of a gas in terms of the motion for its particles and the collisions with the surface. Note that the random motion of microscopic particles in a suspension is evidence for the kinetic particle model of matter. Describe and explain this motion, sometimes known as Brownian motion, in terms of random collisions between the microscopic particles in a suspension and the particles in a gas or liquid. Note that the forces and distance between particles, atoms, molecules, ions, and electrons, and the motion of the particles affects the properties of solids, liquids, and gases. Describe the pressure and changes in pressure of a gas in terms of the forces exerted by particles colliding with surfaces, creating force per unit area. Note that microscopic particles may be moved by collisions with light, fast-moving molecules, and correctly use the terms atoms or molecules as distinct from microscopic properties. Key concept 2.2.1.1 Thermal expansion of solid, liquid, and gases. Learning objectives. Describe quantitatively the thermal expansion of solids, liquids, and gases at constant pressure. Describe some of the everyday applications and consequences of thermal expansion. Explain in terms of the motion and arrangement of particles the relative order of magnitudes of the expansion of solids, liquids, and gases at their temperature rise. Key concept gases and absolute scale and the scale of absolute temperature. Learning objectives. Describe quantitatively in terms of particles the effect on the pressure of a fixed mass of gas of A. A change of temperature at constant volume. B. A change of volume at constant temperature. Recall and use the equation PV is equals to constant for a fixed mass of gas at a constant temperature, including a graphical relationship of the representation of the relationship. Key concept 2.2.2.1 Specific heat capacity. Learning objectives. Know that a rise in the temperature of an object increases its internal energy. Describe an increase in temperature of an object in terms of the increase in average kinetic energies of all the particles in the object. Define specific heat capacity as the energy required per unit mass per unit temperature increase. Recall and use the equation. C is equals to E upon m delta theta. Describe experiments to measure the specific heat capacity of a solid and of a liquid. Key concept 2.2.3.1 Melting, boiling, and evaporation. Learning objectives. Describe melting and boiling in terms of energy input without a change in temperature. Know that melting and boiling temperatures for water at standard atmospheric pressure. Describe condensation and solidification in terms of particles. Describe evaporation in terms of escape of more energetic molecules from the surface of a liquid. Know that evaporation causes cooling of a liquid. Describe the differences between boiling and evaporation. Describe how temperature, surface area, and air movement over a surface affect evaporation. Explain the cooling of an object in contact with an evaporating liquid. 2.3.1.1 Key concept Conduction. Learning objectives. Describe experiments to demonstrate the properties of good thermal conductors and bad thermal conductors, which are also known as insulators. Describe thermal conduction in all solids in terms of atomic or molecular lattice vibrations, and also in terms of movements of free, delocalized electrons in metallic conductors. Describe in terms of particles why thermal conduction is bad in gases and most liquids. Note that there are many solids that conduct thermal energy better than thermal insulators and do so less than good thermal conductors. Key concept 2.3.2.1 Convection. Learning objectives. Know that convection is an important method of thermal energy transfers in liquids and gases. Explain convection in liquids and gases in terms of density changes and describe experiments to illustrate convection. Key concept 2.3.3.1 Radiation. Learning objectives. Know that thermal radiation is infrared radiation and that all objects emit this radiation. Know that thermal energy transfer by a thermal radiation does not require a medium. Describe the effect of surface color black or white and texture dull or shiny on the emission, absorption, and reflection of infrared radiation. Know that for an object to be at a constant temperature, it needs to transfer energy away from the object at the same rate that it receives energy. Note that what happens to an object if the rate of which it receives energy is less or more than the rate at which it transfers energy away from the object. Know how the temperature of the Earth is affected by factors controlling the balance between incoming radiation and radiation emitting from the Earth's surface. Describe experiments to distinguish between good and bad emitters of infrared radiation. Describe experiments to distinguish between good and bad absorbers of infrared radiation. Describe how the rate of emission of radiation depends on the surface temperature and the surface area of an object. Key concept 2.3.4.1 Consequences of thermal energy transfer. Learning objectives. Explain some of the basic everyday applications and consequences of conduction, convection, and radiation, including A. Heating objects such as kitchen pans. B. Heating a room by convection. Explain some of the complex applications and consequences of conduction, convection, and radiation, where more than one type of thermal energy transfer is significant, including A. A fire burning wood or coal. B. A radiator in a car. 3. Waves. Key concept 3.1.1.1 General properties of waves. Learning objective. Know that waves transfer energy without transferring matter. Describe what is meant by a wave motion as illustrated by vibrations in ropes and springs and by experiments using water waves. Describe the features of a wave in terms of wavefront, wavelength, frequency, crest, which is peak, trough, amplitude, and wave speed. Recall and use the equation. V is equal to F lambda. Know that for a transverse wave, the direction of vibration is at right angles to the direction of propagation, and understand that electromagnetic radiation, water waves, and seismic S waves, secondary waves, can be modeled as transverse. Know that for a longitudinal wave, the direction of vibration is parallel to the direction of the propagation of the wave, and understand that sound wave and seismic P waves, primary waves, can be modeled as longitudinal. Key concept 3.1.7 General properties of waves. Learning objectives. Describe how waves can undergo A. Reflection at a plane surface, B. Refraction due to a change in speed, C. Diffraction through a narrow gap. Describe the use of a ripple tank to show A. Reflection at a plane surface, B. Refraction due to a change in speed caused by a change in depth, C. Diffraction due to a gap, D. Diffraction due to an edge. Describe how wavelength and gap size affect diffraction through a gap. Describe how wavelength affects diffraction at an edge. Key concept 3.2.1.1 Reflection of light. Learning objectives. Define and use the terms normal, angle of independence, and angle of reflection. Describe the formation of an optical image by a plane mirror and give its characteristics, i.e., same size, same distance from the mirror, virtual. State that for reflection, the angle of incidence is equal to the angle of reflection. Recall and use this relationship. Use simple constructions, measurements, and calculations for reflection by plane mirrors. Key concept 3.2.2.1 Refraction of light. Learning objectives. Define and use the terms normal, angle of incidence, and angle of refraction. Describe an experiment to show refraction of light through a transparent block of different shapes. Describe the passage of light through a transparent material limited to the boundaries between two medias only. State the meaning of critical angle. Describe internal reflection and total internal reflection using both experimental and everyday example. Define refractive index n as a ratio or the speed of a wave in two different regions. Define refractive index n as a ratio of the speed of a wave in two different regions. Recall and use the equation n is equals to sine I upon sine r. Recall and use the equation n is equals to 1 upon sine c. Describe the use of optical fibers, particularly in telecommunications. Key concept 3.2.3.1 Thin lenses. Learning objectives. Describe the action of thin converging and thin diverging lenses on a parallel beam of light. Define and use the terms focal length, principal axis, and principal focus, also known as focal point. Draw and use ray diagrams for the formation of a real image by converging lenses. Describe the characteristics of an image using the terms enlarged, same size, diminished, upright, inverted, and real/virtual. Note that a virtual image is formed when diverging rays are extrapolated backwards and does not form a visible projection on a screen. Draw ray diagrams for the formation of a virtual image by a converging lens. Describe the use of a single lens as a magnifying glass. Describe the use of converging and diverging lenses to correct long-sightedness and short-sightedness. Key concept 3.2.4.1 Dispersion of light. Learning objectives. Describe the dispersion of light as illustrated by the refraction of white light by a glass prism. Note the traditional several colors of the visible spectrum in order of frequency and in order of wavelength. Recall that visible light of sequent frequency is described as monochromatic. Key concept 3.3.1 Electromagnetic spectrum. Learning objectives. Know the main regions of the electromagnetic spectrum in order of frequency and in order of wavelength. Know that all electromagnetic waves travel at the same speed in a vacuum. Describe the typical uses of different regions of the electromagnetic spectrum, including A. Radio waves, radio and television telecommunications, astronomy, radio frequency, and identification. RFID. Microwaves. Satellite television, mobile phones, cell phones, microwave ovens, infrared, electric grills, short-range communications such as remote controllers for televisions, intruder alarms, thermal imaging, optical fibers. Visible light, vision, photography, illumination. Ultraviolet, security, marking, detecting fake banknotes, sterilizing water. X-rays, medical scanning, security scanners. Gamma rays, sterilizing food and medical equipment, detection of cancer and its treatment. Describe the harmful effect on people of excessive exposure to electromagnetic radiation, including microwaves, internal heating of body cells, infrared, skin burns, ultraviolet, damage to surface cells and eyes leading to skin cancer and eye conditions. D. X-rays and gamma rays, mutation or damage to cells in the body. Though the communication with artificial satellites is mainly by microwaves. A. Some satellite phones use low-orbit artificial satellites. B. Some satellite phones and direct broadcast satellite television use geostationary satellites. Note that the speed of electromagnetic waves in vacuum is 3 into 10 to the power 8 meters per second and is approximately the same in air. Note that many important systems of communication rely on electromagnetic radiation, including A. Mobile phones, cell phones, and wireless internet using microwaves because microwaves can penetrate some walls and only require short area for transmission and reception. B. Bluetooth uses radio waves. Radio waves pass through walls and signal is weakened on doing so. Optical fibers, visible light or infrared, are used for cable television and high-speed broadband because glass is transparent to visible light, and some infrared visible light and short wavelength infrared can carry high rates of data. Note the difference between a digital and analog signal. Note that a sound can be transmitted as digital or analog signal. Explain the benefits of digital signaling, including increased rate of transmission of data and increased range due to accurate signal regeneration. Key concept 3.4.1 Sound. Describe the production of sound by vibrating sources. Describe the longitudinal nature of sound waves. State the approximate range of frequencies audible to humans as 20 Hz to 20,000 Hz. Note that a medium is needed to transfer sound waves. Describe how changes in amplitude and frequency affect the loudness and pitch of sound waves. Describe compression and rarefaction. Know that in general sounds travels faster in solids than in liquids and faster in liquids than in gases. Key concept 3.4.9 Sounds. Define ultrasound as sound with a frequency higher than 20,000 Hz. Describe the use of ultrasound in non-destructive testings of material, medical scanning of soft tissue, and sonar, including calculation of depth or distance from time and wave speed. Note that the speed of sound in the air is approximately 330 to 350 meters per second. Describe a method involving a measurement of the distance and time for determining the speed of sound in air. Describe an echo as a reflection of sound waves. Number 4. Electricity and magnetism. Key concept 4.1.1 Simple phenomena of magnetism. Learning objectives. Describe the forces between magnetic poles and between magnets and magnetic materials, including the use of the terms North Pole, N pole, South Pole, S pole, attraction and repulsion, magnetized and unmagnetized. Describe induced magnetism. State the difference between magnetic and non-magnetic materials. Key concept 4.1.5 Simple phenomena of magnetism. Learning objectives. Describe a magnetic field as a region in which a magnetic pole experiences a force. Draw the pattern and direction of magnetic field lines around a bar magnet. State that the direction of magnetic field at a point is the direction of the force on the end pole of a magnet at that point. Describe the plotting of magnetic field lines with the compass or iron fillings and use of the compass to determine the direction of the magnetic field. Explain that magnetic forces are due to interactions between magnetic fields. Note that relative strength of a magnetic field is represented by the spacing of the magnetic field lines. Key concept 4.1.3 Simple phenomena of magnetism. Learning objectives. State the differences between the properties of temporary magnets, which are made of soft iron, and the properties of permanent magnets, which are made of steel. Describe uses of permanent magnets and strong electromagnets. Key concept 4.5.3.1 Magnetic effect of current. Learning objectives. Describe the pattern and the direction of the magnetic field due to currents in straight wires and in solenoids. Describe an experiment to identify the pattern of the magnetic field, including direction, due to currents in straight wires and solenoids. State the quantitative variation of the strength of magnetic field around straight wires and solenoids. Describe the effect on the magnetic field around straight wires and solenoids of changing the magnitude and direction of current. Key concept 4.2.1.1 Electric charge. Learning objectives. State that there are positive and negative charges. State that positive charges repel other positive charges and negative charges repel other negative charges, but positive charges attract negative charges. Describe simple experiments to show the production of electrostatic changes by friction and to show the detection of electrostatic charges. Explain that charging of solids by friction involves only a transfer of negative charges, which are electrons. State that charge is measured in coulombs. Key concept 4.2.1.8 Electric charge. Describe an electric field as a region in which an electric charge experiences a force. State that the direction of an electric field at a point is the direction of the force on a positive charge at that point. Describe simple electric field patterns, including the direction of the field. A. Around a point charge. B. Around a charged conducting sphere. C. Between two oppositely charged parallel conducting plates. And effects will not be examined. Key concept 4.2.1 Electric charge. Learning objectives. Describe an experiment to distinguish between electrical conductors and insulators. Recall and use a simple electronic model to explain the difference between electrical conductors and insulators, and give typical examples. Key concept 4.2.2.3 Electric current. Learning objectives. Describe electrical conduction in metals in terms of movement of free electrons. Key concept 4.2.2.1 Electric currents. Learning objectives. Note that electric current is related to the flow of charge. Describe the use of ammeters, analog and digital, with different ranges. Note the difference between DC, which is direct current, and AC, which is alternating current. Define electric current as a charge passing a point per unit time. Recall and use the equation I is equals to Q upon T, or Q is equals to IT. State that convectional current from positive to negative and that the flow of electrons is from the negative to the positive. Key concept series and parallel circuits. Learning objectives. Note that the current at each point in a series current circuit is the same. State that for a parallel circuit, the current from the source is larger than the current in each branch. Recall and use in calculations the fact that A, the sum of current entering junctions in a parallel circuit is equal to the sum of currents that leave the junction. Explain the sum of currents in a junction is the same as the sum of the currents out of the junctions. Key concept 4.2.3.1 Electromotive force and potential difference, also known as EMF and PD. Define electromotive force EMF as the electrical work done by a source in moving a unit charge around the complete circuit. Note that EMF is measured in volts, V. Define potential difference as the work done by the unit charge passing through a component known as the PD between 2 points is measured in V, volts. Describe the use of voltmeters, analog and digital, with different ranges. Recall and use the equation for EMF. E is equal to W upon Q. Recall and use the equation for PD. Voltage, V is equals to W upon Q. Key concept 4.3.2.3 Series and parallel. Learning objectives. Calculate the combined EMF for several sources in series. Recall and use the equations. The fact that B, total PD across the components in a series circuit is equal to the sum of the individual PDs across each component. C, the PD across an arrangement of parallel resistances is the same as the PD across one branch in the arrangement of the parallel resistances. Key concept 4.2.4.1 Resistance. Learning objectives. Recall and use the equation for resistance. R is equals to V upon I. Describe an experiment to determine resistance using a voltmeter and an ammeter and do the appropriate calculations. State quantitatively the relationship of the resistance of a metallic wire to its length and cross-sectional area. Sketch and explain the current voltage graphs of a resistor of constant resistance, a filament lamp, and a diode. Recall and use the following relationship for a metallic electrical conductor. A. Resistance is directly proportional to length. B. Resistance is inversely proportional to cross-sectional area. Calculate the combined resistance of two or more resistors in series. State that the combined resistance of two resistors in parallel is less than that of either resistor by itself. Calculate the combined resistance of two resistors in parallel. Key concept 4.3.1.1 Circuit diagrams. Draw and interpret circuit diagrams containing cell, batteries, power, supplies, generators, potential dividers, switches, resistors fixed on variables, heaters, thermistors, NTC only, light-dependent resistors, lamps, motors, amp meters, voltmeters, magnetizing coils, transformers, fuses, relays, and note that how these components behave in a circuit. Draw and interpret circuit diagrams containing diodes and light-emitting diodes, LEDs, and know how these components behave in a circuit. Know how to construct and use series and parallel circuits. State the advantages of connecting lamps in parallel and in a lightning circuit. Note that the potential difference across an electrical conductor increases as its resistance increases for a constant current. Describe the action of a variable potential divider. Recall and use equations for two resistors used as a potential divider. R1 upon R2 is equals to V1 upon V2. Key concept 4.2.5.1 Electrical energy and electrical power. Learning objectives. Understand that electrical circuits transfer energy from a source of electrical energy, such as an electrical cell or main supplies, to the circuit's components and then to the surroundings. Recall and use the equation for the electrical power. P is equals to IV. Recall and use the equation for electrical energy. E is equals to IV into T. Define the kilowatt hour, kWh, and calculate the cost of using electrical appliances where the energy unit is kWh. Key concept 4.4.1 Electrical safety. Learning objectives. State the hazards of A. Damaged installation, B. Overheating cables, C. Damp conditions, D. Excess current from overload of plugs, extension loads, single and multiple sockets when using a main supply. Know that a main circuit consists of a live wire, a neutral wire, and an earth wire, and explain why a switch must be connected to the live wire of the circuit to be switched off safely. Explain and use the operation of trip switches and fuses and choose appropriate fuse ratings and trip switch settings. Explain why the outer casting of an electric appliance might be either non-conducting, double insulated, or earthed. State that a fuse without an earth wire protects the current and the cable for double insulated appliance. Key concept 4.5.3.3 Magnetic effect of a current and force on a current carrying conductor. Learning objectives. Describe how the magnetic effect of a current is used in relays and loudspeakers and give examples of their application. Describe an experiment to show that a force acts on a current carrying conductor in a magnetic field, including the effects of A. The current, B. The direction of the field. Recall and use the relative directions of force, magnetic fields, and current. Determine the direction of force on beams of charged particles in a magnetic field. Key concept 4.5.5.1 The DC motor. Know that a current-carrying coil in a magnetic field may experience a turning effect and that the turning effect is increased by increasing A. The number of turns on the coil, B. The current, C. The strength of the magnetic field. Describe the operation of an electric motor, including the action of a split-ring commutator and brushes. Key concept Electromagnetic induction. Know that a conductor moving across a magnetic field or a changing magnetic field linking with a conductor can introduce an EMF in the conductor. Explain the experiment to demonstrate electromagnetic induction. State the factors affecting the magnitude of an induced EMF. Know the direction of an induced EMF opposes the charge causing it. State and use relative directions of force, field, and induced current. Key concept 4.5.2.1 The AC generator. Learning objectives. Describe a simple form of an AC generator, rotating coil, or rotating magnet, and use of slip rings and brushes where needed. Sketch and interpret graphs of EMS against time for simple AC generators and relate the position of the generator coil to the peaks, troughs, and EMFs and zeros of the EMF. Key concept 4.5.6.1 Transformer. Describe the construction of a simple transformer with a soft iron core as used for voltage transformations. Use the terms primary, secondary, step up, step down. Recall and use equation Vp upon Vs is equals to Np upon S, where P and S refer to primary and secondary. Describe the use of transformer in high voltage transmission of electricity. State the advantages of high voltage transformation. Explain the principle of operation of a simple iron core transformer. Recall and use the equation for 100% efficiency in a transformer. IPVP is equals to ISVS, where P and S refer to primary and secondary. Recall and use the equation P is equals to I squared R to explain why power losses in cables are smaller than the voltage is greater. Number 5. Nuclear physics. Key concept 5.1.1.1. The atom. Learning objectives. Describe the structure of an atom in terms of a positively charged nucleus and negatively charged electrons in the orbit around the nucleus. Know how many atoms may form positive ions by losing electrons or form negative ions by gaining electrons. Describe how the scattering of alpha particles by a sheet of thin metal supports the nuclear model of the atom by providing evidence for A. A very small nucleus surrounded by mostly empty space, B. A nucleus containing most of the mass of an atom, C. A nucleus that is positively charged. Key concept 5.1.2.1. The nucleus. Describe the composition of the nucleus in terms of protons and neutrons. State the relative charges of protons, neutrons, and electrons as positive 1, 0, and negative 1 respectively. Define the terms proton number, which is atomic number, Z, and nucleon number, which is the mass number, A, and be able to calculate the number of neutrons in a nucleus. Use the nuclide notation, x to the power A, Z. Explain what is meant by an isotope and state that an element may have more than one isotope. Know the relationship between the proton number and the relative charge on a nucleus. Know the relationship between the nucleon number and the relative mass of the nucleus. Key concept 5.2.2.1. The 3 types of emission. Learning objectives. Describe the emission of radiation from a nucleus as spontaneous and random in direction. Define alpha, beta, and gamma emissions from the nucleus by recalling A. Their nature, B. The relative ionizing effects, C. The relative penetrating abilities, B+ are not included, B- particles will be taken to refer as negative beta. Describe the deflection of alpha particles, beta particles, and gamma radiation in electric fields and magnetic fields. Explain the relative ionizing effects with reference to A. Kinetic energy, B. Electric energy. Key concept 5.2.3.1. Radioactive decay. Know that radioactive decay is a change in an unstable nucleus that can result in the emission of alpha particles or beta particles and or gamma radiation, and know that these changes are spontaneous and random. State that during alpha decay or beta decay, the nucleus changes to that of a different element. Know that isotopes of an element may be radioactive due to an excess of neutrons in the nucleus and or the nucleus being too heavy. Describe the effect of alpha decay, beta decay, and gamma radiations or emissions on the nucleus, including an increase in stability and a reduction in the number of excess neutrons. The following change in the nucleus occurs during beta emission. Neutron breaks up into proton plus electron. Using decay equations, using nuclide notation to show the emission of alpha particles, beta particles, and gamma radiation. Key concept 5.2.1.1. Detection of radioactivity. Know what is meant by background radiation. Know the sources that make a significant contribution to background radiation, including A. Radon gas in the air, B. Rocks and buildings, C. Food and drink, D. Cosmic rays. Know that ionizing radiation can be measured using a detector connected to a counter. Use count rate measures in count per second or counts per minute. Use measurements of background radiation to determine a corrected count rate. Key concept 5.2.4.1. Half-life. Learning objectives. Define the half-life of a particular isotope as the time taken for half its nuclei of that isotope in any sample to decay. Recall and use this definition in simple calculations, which might involve information in tables or decay curves. Calculations will not include background radiation. Calculate half-life from data or decay curves from which background radiation has been subtracted. Explain how the type of radiation emitted and the half-life of the isotope determine which isotope is used for applications, including A. Household fire smoke alarms, B. Irradiating food to kill bacteria, C. Sterilization of equipment using gamma rays, D. Measuring and controlling thickness of materials with the choice of radiations used linked to penetrate and absorption, diagnosis and treatment of cancer using gamma rays. Key concept, the nucleus. Learning objectives. Describe the process of nuclear fission and nuclear fusion as the splitting or joining of nuclei to include the nuclide equation and qualitative description of mass and energy changes without values. Key concept. Safety precautions. Learning objectives. State the effect of ionizing radiations on living things, including cell death, mutations, and cancers. Describe how radioactive materials are moved, used, and stored in a safe way. Explain why precautions for all ionizing radiations in terms of reducing exposure time, increasing distance between the source and the living tissue, and using shield to absorb radiation. Number 6. Space physics. Key concept, the Earth. Learning objectives. Note that the Earth is a planet that rotates on its axis, which is tilted once in approximately 24 hours, and use this to explain observations of the apparent daily motion of the Sun and the periodic cycle of day and night. Note that the Earth orbits around the Sun once in approximately 365 days, and use this to explain the periodic nature of seasons. Note that it takes approximately 1 month for the Moon to orbit the Earth, and use this to explain the periodic nature of the Moon's cycle of phases. Define average orbital speed from the equation v is equals to 2 pi r upon t, where r is the average radius of the orbit and t is the orbital period. Recall and use this equation. 6.1.2.1 The Solar System. Describe the solar system as containing A. 1 star, the Sun, B. the 8 named planets and know their order from the Sun, C. minor planets that orbit the Sun, including dwarf planets such as Pluto and asteroids in the asteroid belt, D. moons that orbit the planets, E. smaller solar system bodies including comets and natural satellites. Note that in comparison to each other, the 4 planets nearing the Sun are rocky and small, and the 4 planets further away from the Sun are gaseous and large, and explain this difference by referencing to an acceleration model for solar system formation to include A. the model's dependency on gravity, B. the presence of many elements in interstellar clouds of gas and dust, C. the rotation of material in the cloud and the formation of an resurrection disk. Note that the strength of the gravitational field A at the surface of the planet depends on the mass of the planet, B around a planet decreases as the distance from the planet increases. Note that the Sun contains most of the mass of the solar system, and this is what explains why the planet orbits the Sun. Note that the force that keeps an object in orbit around the Sun is the gravitational attraction of the Sun. Note that planets, minor planets, and comets have elliptical orbits, and recall that the Sun is not the center of the elliptical orbit, except where the orbit is approximately circular. Analyze and interpret planetary data about orbital distance, orbital period, density, surface temperature, and uniform gravitational field strength at the planet's surface. Note that the strength of the Sun's gravitational field decreases, and that the orbital speeds of the planets decrease as the distance from the Sun increases. Note that an object in an elliptical orbit travels faster when closer to the Sun, and explain this using conservation of energy. Key concept, the solar system. Learning objectives. Calculate the time it takes to travel a significant distance, such as between objects in the solar system. Key concept, the Sun as a star. Learning objectives. Know that the Sun is a star of a medium size consisting mostly of helium and hydrogen, and that it radiates most of its energy in the infrared, visible, and ultraviolet regions of the electromagnetic spectrum. Note that stars are powered by nuclear reactions that release energy, and that in the stable stars, the nuclear reactions involve the fusion of hydrogen into helium. Key concept, stars. Learning objective. States that galaxies are made up of many billions of stars. The Sun is a star in the galaxy known as the Milky Way. Other stars that make up the Milky Way are way much further away from the Earth than the Sun is from the Earth. D. Astronomical distances can be measured in light years, where the light year is the distance traveled in the vacuum of space by light in 1 year. Note that 1 light year is equals to 9.5 into 10 to the power 15 meters. Describe the life cycle of a star. A. A star is formed from interstellar clouds of gas and dust that contain hydrogen. B. A protostar is an interstellar cloud collapsing and increasing in temperature as a result of its internal gravitational attraction. C. A protostar becomes a stable star when the inward force of gravitational attraction is balanced by an outward force due to the high temperature in the center of the star. All stars eventually run out of hydrogen as fuel for the nuclear reaction. E. Most stars expand to form red giants when most of the hydrogen in the center of the star has been converted to helium. F. A red giant from a less massive star forms a planetary nebula with a white dwarf at its center. G. A red supergiant explodes as a supernova, forming a nebula containing hydrogen and new heavier elements, leaving behind a neutron star or a black hole at its center. H. The nebula from a supernova may form new stars with orbiting planets. Key concept: the universe. Learning objectives. Note that the Milky Way is one of the billions of galaxies making up the universe, and that the diameter of Milky Way is approximately 100,000 light years. Describe redshift as an increase in the observed wavelength of electromagnetic radiation emitted from receding stars and galaxies. Note that the light emitted from distant galaxies appears redshift in comparison to light emitted on the Earth. Note that the redshift in the light from the distant galaxies is evidence that the universe is expanding, and this supports the Big Bang theory. Note that microwave radiation of a specific frequency is observed at all points in space around us and is known as cosmic microwave background radiation, CMBR. Explain that the CMBR was produced shortly after the universe was formed and that this radiation has been expanded into the microwave region of the electromagnetic spectrum as the universe expanded. Note that the speed v at which a galaxy is moving away from the Earth can be found from the change in the wavelength of the galaxy's starlight due to redshift. Note that the distance of a far galaxy D can be determined using the brightness of a supernova in that galaxy. Define the Hubble constant, HO, as a ratio of the speed at which the galaxy is moving away from the Earth to its distance from the Earth. Recall and use the equation. HO is equal to V upon D. Note that the current estimate for HO is 2.2 into 10 to the power minus 18 per second. Note that the equation d upon v is equals to 1 upon HO represents an estimate for the age of that universe, and that is the evidence for the idea that all matter in the universe was present at a single point. This completes our scheme of work for Cambridge IGCSE 0625.